The moon was the first place humans tried to reach beyond Earth as the space age began in the late 1950s. More than half a dozen countries have since sent spacecraft to the moon. 9 manned missions have flown to the moon and back. However, as multiple nations continued plotting out their moon exploration strategies, space engineers were given cold sweats on how best to survive the lunar night. How best do you think they could? Stay till the end as we explain why the lunar night is dreaded and the best way to survive it. The moon is an important part of us, as it's our closest celestial body in the solar system, our real satellite, and our next logical step for a permanent presence. This importance manifests with NASA preparing for a permanent presence on the moon with the Artemis program, designed to maintain U.S. leadership in space research and build global alliances. This mission intended to land the first woman and first person of color on the moon in 2024 and initiate collaboration with international and commercial partners to form a base camp, allowing lunar exploration in the mid to late 2020s. Howard Hu, the head of the U.S. agency Orion Lunar Spacecraft Program, said humans would be living and working on the moon by the end of this decade. NASA will provide them with habitable homes and rovers to support their work. He further said that in this decade, they plan to have people living for durations, depending on how long they'll be on the moon's surface. He said they would continue sending people up to the moon, living there and doing science. What did Hu mean by doing science? They plan to make the moon a base for astronauts. A moon base holds the potential to be a significant stepping stone to exploring more of our solar system, especially Mars, and would also allow us to conduct more science than ever before, contributing to our understanding of our planet as well as the rest of our galaxy and universe. However, these plans and missions for establishing a permanent residence on the moon face a great challenge: the lunar night. The lunar night is the number of days intense darkness envelops the moon. Because one rotation of the moon lasts around 28 days on Earth, the lunar night, which is when the surface of the moon is not exposed to the sun, lasts about 14 days of constant darkness and intense cold. This process means that in this long night cycle, temperatures drop drastically, down to about -280 degrees Fahrenheit. Even permanently shadowed regions on the moon can be colder, plunging to -400 Fahrenheit, creating an incredibly intense environment and destroying the capabilities of most equipment. The circumstance is one of the most challenging environmental demands that future moon expeditions will face. Achieving and gaining longer and longer human stays, gaining permanent status, will mean coming to grips with the moon's vicious environment. Moon exploration strategists are laying out what has to happen to operate successfully on the moon, especially at the lunar South Pole, loaded with PSRs and maybe a rich haven for harvesting water ice. But it isn't easy. During the prolonged night, when the surface is lit only by blue Earth light, temperatures plunge below -170 degrees Celsius. Some locations at elevated latitudes have shorter nights, though others have much longer or permanent darkness. Although this kind of prolonged darkness occurs in some of Earth's countries, European countries like Finland, Sweden, Norway, and in the US, Alaska, many of others experience situations where the sunset doesn't occur, especially in the summer, and consecutive darkness in the winter. However, the coldness isn't as intense as what humans will deal with on the moon. The intense cold and darkness during lunar nights on the moon have destroyed numerous robotic missions. For instance, Russia's Lunokhod 2 rover failed to make it through the night in May 1973. Its radioactive heater having run down gradually after 4 months of exploring. The successful Apollo manned missions stayed on the surface only a few days at a time and throughout the early lunar morning. But future lunar inhabitants will have to live in the night as well as the day, keeping in mind that vital solar energy and heat won't be available during the 14 days of darkness. Surviving the night on the moon isn't the only key issue for a lunar South Pole site, but for any place on the moon's surface. Dean Epler, a chief lunar scientist at the Aerospace Corporation, said he thinks the basic problem has 2 branches. In an interview with Space.com, He said for future missions, particularly for landed missions off the polar latitudes, hunkering down may still be the best decision for science operations. Epler said field geology isn't what you'll be doing at night, but that time is probably for inside activities like sample analysis, life science, and culling, and others. Those tasks are not carried out during the day when crew members maximize their surface time and tour the moon. He further said he's optimistic about taking on lunar nights because they're better equipped to handle that now. Epler also talked about the extremity of the cold during this night. Although surviving the lunar night outside the polar regions is still an issue, he thinks the aerospace industry has that in hand, as that too goes for areas of the poles shadowed by the subsisting terrain as the sun travels around the sky. However, Epler sees a much more complicated problem when it comes to the poles. Firstly, there'll be important areas that get shadowed by the terrain long enough that it's going to get very cold in those locations, although not PSR cold, but still not unlike the equatorial night. Additionally, Epler suggested that we must deal with the problems of working in any area, either PSR or those still shadowed much of the time, even when not in permanent darkness. This coldness is a huge challenge and requires a special set of tools we will use in cold conditions. How could we survive this intense cold and darkness? Scientists came up with different views of saving astronauts' life over there. Philip Metzger, who's a planetary scientist with the Florida Space Institute at the University of Central Florida, said coping with the extraordinary cold shouldn't be an unsolvable problem. The vehicle can stay warm with just a little energy and good insulation. He uses the New Horizons spacecraft as a case study. The spacecraft kept its electronics at room temperature even when it was at Pluto, very far from the sun. However, the question is, where can we get the energy on the moon? Metzger suggests using radioactive decay sources. He said radioactive heater units could be placed on the vehicle at appropriate points. Still, it'll become more challenging without a radioactive source. He envisions a standalone asset with adequate battery capacity to provide the required warmth throughout the night. A rover could plug in during the night. After sunrise, the battery will recharge. That would take some space on the moon for adequate storage, but with the new lunar landers, including the SpaceX Starship coming online, it should be easily doable. However, ESA's Moritz Fontaine has a contradicting opinion. He said that radioactive heat had been the preferred solution for lunar habitats, but these would only multiply the cost and complexity of any expedition. So the ESA is trying to explore a more sustainable solution, using the capacity of moon dust to absorb and store energy when sunlight hits, and then releasing this stored energy during the lunar night. Simple. The basic concept of this process involves using multiple mirrors to channel sunlight into processed lunar regolith, into which a heat engine would be placed. Driven by the temperature difference, the process would keep this heat engine running directly by the heat of the sun during the day, while simultaneously storing excess heat in the soil. Once night falls, the moon dust would keep the heat engine running by gradually releasing the energy from the heated soil. Moritz assured that the principle had been worked out in detail, and the next step, being taken on by ESA's General Studies program, is to execute numerical and simulation studies to put importance on the heat storage and electricity provisions the system would enable. More so, the upgraded moonwalking suit could be part of survival for astronauts on the moon. Because NASA is looking to ensure that when they return to the moon, they stay permanently, they designed this suit with a much higher range of temperature variances to ensure it can serve at both the north and south poles of the moon, as well as around the equatorial region. This XEMU suit is designed to survive temperatures between -250 and +250 degrees Fahrenheit. Also, the next generation radioisotope power systems RPSs are poised to overcome this barrier. According to NASA, currently, there are only two practical, reliable ways to power our spacecraft: the heat from the sun and heat from nuclear sources. Solar power provides an excellent power source for certain missions, but RPSs, essentially, nuclear batteries that convert or channel heat into electric power, are necessary to explore the darker, colder areas in our solar system. RPSs have made historic contributions to space exploration over 60 years and continue to power space exploration today. Michael Smith, a nuclear space systems engineer at the Oak Ridge National Laboratory, said that the radioisotope power systems don't have moving parts that can get damaged during removal and re-entry. They're rocket-proof, so it's hard to think of another well-suited system for powering spacecraft. Because these RPSs can withstand extremely cold temperatures, they can survive the lunar night and be used as early-stage power systems for remote imaging and communications. NASA aims to put humans on the moon by 2030, living and working up there. They plan to make the moon a base for further deep space exploration. However, they are mindful of the potential danger that hovers around. The lunar night, accompanied by extreme coldness, could destroy the space engines. If this happens, astronauts will get stranded. And what next? Death. This effect is why scientists are looking for a way to survive the dreaded circumstance.